Afternoon. It's a privilege to be back at Webb. I was in those chairs 30 years ago on a regular basis, and now it's better not to be having my papers graded. So,
I don't know.
so basically at Lloyd's Register, I'm a principal engineer in the applied technology group. And I'm in the nuclear group there. So it's pretty fascinating stuff. And I'm going to talk a little bit about how we see nuclear power coming together for commercial and maritime applications, commercial maritime and offshore applications. First thing is nuclear ship Savannah. Arguably the most beautiful ship ever built. No, it is the most beautiful ship ever built. And for me, it's also special. When my wife and I got married here almost 20 years ago, I named the tables, and the head table was NS Savannah. So 1955, this was a theoretical idea from President Eisenhower. 1959, it was started building. 1962, delivered and working on the high seas. There are a couple things in there that are really interesting. One, first civilian application of nuclear power in the world. Two, it was the centerpiece for the Atoms for Peace program. It basically set the tone for the Cold War. So this ship is a big deal. Plus, it looks really good. Lloyd's Register, been around for a while, formally founded in 1760, but really got going in the late 1600s in a coffee shop in London. So nuclear is very, very fashionable now. And I would say it's fashionable on the large ships. Now, it's been around for a while, Savannah being 1960-ish. The Nautilus, the first true nuclear vessel, first true submarine, first thing to traverse the North Pole. A lot of firsts in that, and only a couple of years ahead of Savannah. The U.S. Navy operates, I believe, about 70 reactors in its surface and subsea fleet, making it the largest operator of nuclear reactors of any type in the world. Otto Hahn and Mutsu were German and Japanese ships, respectively, in the merchant trade nuclear, and the Russians have some icebreakers that work in the nuclear trade. So it's not new. Nuclear is becoming fashionable, in part because of pressures from decarbonization. Now, there are a lot of things going on in the world. So the nature of shipping is changing internally. It's ready to go. And the nature of trade is also changing for some pretty big pushes. So today, shipping is about 3% of the global GHG emissions, which if it were a country, it'd be about number 5 up there with Germany. So you might say, ooh, 3% is not very much, but it attracts attention. And if we don't get our act together, it'll be about 15% before 2050. So take it as a thesis, things have to change. Low carbon technologies are awesome for like little boats, harbor ferries. I mean, I love the little micro sailing stuff. That is so cool. But for big tankers, for offshore power or offshore floating production, it's not going to work. So it's different. So in the nature of shipping, going back to that large scale look, the internal competition is fierce. So that means it's really hard to put forward a new idea or innovation and get it to stick. And hopefully you don't get killed in the process. And that means the nature of trade is the external force. And decarbonization is really that force right now at the moment. But we're also seeing some other things. COVID, Ukraine, and others are now reinforcing a thing in trade and economic security, which is pushing towards what you might call resilient supply webs instead of brittle supply chains. That's going to change shipping. Basically, what I'm getting at is nuclear is an enabler, and it's pretty cool. And the timing is good. Right now, we're 3 years into the UN Decade of the Ocean. And so we've got 7 years while we got the spotlight on us to do something cool. Okay. Nuclear is timely for a couple of reasons. Ships with long ranges. I'm talking about tankers, container ships to go, probably 5, 10, 20,000 miles on a single refueling. Have a high power requirement. Let's start medium size, 30 megawatts and up, and long lives. Tankers have an economic life of 20 years, LNG about 30 years, container ships somewhere. Those are good. Alternative fuels, let's look at ammonia, methanol, hydrogen, all these. They have varying decarbonization benefits and all have their challenges of one form or another. Offshore is much higher power requirements. So a 250,000 barrel per day floating production unit will probably have 4 or 5 GE LM2500s and another half dozen solar or Baker Hughes compression turbines on there. So they'll be marching towards 150 megawatts of power that they're using every day for 30 years. They have very long lives, 20 to 50 years. They can also be grid connected. And that gets interesting, especially on the higher voltages. And then with suitable turn down or load following capability, this could actually look at how to deal with renewables, because once renewables can be considered dispatchable power, there's no stopping there. Right now, from what I've seen and from what I've heard, renewables, solar and wind, unsubsidized and only selling 30% of the power, they're lower costs than natural gas as power. So if you can provide the stability some way, somehow, that's just going to open the door. And then floating power or floating production can also provide municipal or industrial power supply. There are a lot of sort of, I'd say, licensing arrangements that favor floating or sea units over land-based. Okay, big container ship. I'm showing pictures of various applications that would look good with a nuclear reactor on board. So if we break it down into just a couple different sizes, smaller than 10 megawatts, small ships, small rigs, they're islanded. They're not going to do much. They're going to stay contained. About more than 10,000 of these things that float, very cost conscious. I wouldn't really look to see anything in that group just yet. The 10 to 50 megawatt range are medium-sized ship, medium-sized rigs, islanded and shore power. So that'll cover your drill ships, your large tankers, LNG, a pretty large raft. And there are also more than 10,000 of these vessels, but they're mixed. Some are cost conscious, let's say dry bulk, and some work in a premium market like LNG. The 50 to 100 megawatt range, these are big ones, big ships and medium-sized floaters, and they can work in islanded, shore power, microgrid situations, but there are fewer than 5,000 of these units. But there's a good market potential here, and there's a growth market, I believe. The offshore systems, greater than 100 megawatts, some marching up towards 1 gigawatt. Those are all kinds of places. This is a growth market. There are fewer than 500 of those. No, I'm not going to go through all of these. These are for you to read later. But basically, in the nature of trade, you have the revolution, quasi-revolution, revolution. All of these are applications where nuclear can really change the market that they're going into. The other ones are replacement, just basically replacing fuel, diesel fuel, well, heavy fuel, with nuclear. Container ships are the interesting ones in the sense that the nature of trade is changing, and container ships are really poor at carrying cargo. When you look at the container and everything else, they don't carry much stuff. So depending on how the container market works, they'll either become the victim or the victor of this whole new world. But some of these in the revolution category can be new trade types, and that'll get interesting. LNG ship, some of the changes. So design changes. You can say, oh, what kind of size? Not much change. They're really not going to change much. And those of you who get in design, the weight or the mass of the ship is always really, you're always really having a hard time with it. But that's a local problem. Weight is not really a big issue. Like, let's say, trucks, railroad, aircraft, or any other kind of transport mode. Electrical systems, nuclear does very well with electrical. It generates electricity. So on the larger one, we'll see AC. But then even some of the power generation major utilities are moving towards 1 million volt DC distribution. So yeah, there's some pretty cool things out there. And then fully integrated electric bus systems, the way to go. Easier to integrate. Basically, you're generating electricity. Although in offshore floaters, you'll also be taking some of the heat off for the process equipment. And long design life. If you can get 50 years out of this, shouldn't be difficult, much better. Operational changes are much more difficult. You'll need specialized training for nuclear. It took 15, 20 years to do the steam to diesel changeover, but it happened. But something is interesting about this, because in the inspection, maintenance, repair model and the financing model, what we're seeing is some of the OEMs are interested in the leasing model, or power by the hour, which is great because that means you're leasing their time and you're basically buying their megawatts. You're not delivered fully on. So this is more akin to aviation. It also means the accountability for decommissioning goes back to the owner or the OEM, which is kind of cool. And they're also taking that big CapEx chunk out from you at the front end. But what we have to get used to is, this is for the nuclear people, ships go everywhere, spend a lot of time in isolation, you go in rough places, and there are colorful characters and sketchy characters. So that whole security and safeguarding business, that's everybody's question, that's a big deal. So you bring in the nuclear regulators to help you on board. But shipping has led major changes. Oil-fired boilers, high-pressure steam, large diesels up to 100 megawatts. Remember the first nuclear application civilian was a ship. We need structural changes, though. Chartering model has got to change. I don't know how to do it. If you could, that's going to be wonderful. But that's an entire 2-day long conference by itself. We need to get the useful life of the assets up greater than 30 years. And that'll be great. Financing, we need to get shipping companies comfortable with the idea of actually power by the hour. They like to own things and keep everybody out. And then strategic partnerships have to be formed that don't exist. You have to build real OEM relationships with the shipyards. But right now, they're commodity builders, building for production, not for operations. So that's got to change. And you have to have greater operator engagement with the charterer, the shipyard, the OEMs. For you guys in MBA school, you're basically trying to go from a red ocean to a blue ocean. I would say, just throwing it in there, the external forces also include regulatory. And this isn't just about today. It goes back to the past. We go coal to oil. Churchill mandated it for the Royal Navy. So that's how oil came into the picture. The switch from steam to diesel were the events of OPEC 73 and OPEC 79. Those crises kind of got people to move. And that really got the diesel part going. And then low sulfur fuel. Remember in 2020, the whole low sulfur fuel debate? 2018, 2019, everybody was going, the sky is falling, not possible, everything else is too hard to do, we don't have enough time to do it. That was enacted in 2005. So they had time. You've already used up half a ship life. So basically, we're getting back to things are going to change, but we're going to have to do it on our own. Don't wait on your own. So a little bit about the class and regulatory parts, because that's boring, but that's also why we're here. So there are two international agencies that come into this. One is the IMO, International Maritime Organization. That's basically the MARPOL, SOLAS, and a whole bunch of other things. But basically, this falls really into SOLAS category, safety of life at sea. And then we bring in the International Atomic Energy Agency. Owes its foundation to Savannah again. Savannah is full of firsts. So these two have to work together, and that's actually part of my work at my company. Then we have to look at flag states and port coastal states. Now, the flag states are kind of an interesting group because they're remarkably uniform in terms of their requirements, but not so uniform in terms of their enforcement. And then flag states get really tricky when we talk about nuclear, because they either have to be part of the Paris Convention, or they have to have some sort of deal with a nuclear regulatory, or a country with a good nuclear regulatory regime, let's say Canada or the United States, for example, in order to make it work. And then everything at the IMO moves slow. I think Eric Linsner can tell you that. I've lived it. And then the port coastal states have to be brought into it too, and they can bring in their own flavor. Class societies are really important. And the class societies, I should say, they're not a government, they're not a government agency, but they can almost, they're basically a proxy regulator, because the class rules get pulled in by either through incorporated by reference or something else. So they're in there. And then IACS is the group of major class societies, of which LR is one, ABS is another, DNV, and I think they're back up to 12. So for those of you in shipping, they're older, anachronistic philosophies, but they're uniform. For offshore, they're more modern, but it's kind of all over the place. SOLAS 8, Chapter 8, is undergoing a major rewrite. I'd say it should be going under its first right, because its old version is basically nothing more than table contents. The Resolution A491-12 Code of Safety for Nuclear Ships is beautifully written, and it was adopted in 1981. It hasn't changed since then. So that was contemplating pressure water reactors, which are not the ones that are the favored today, because pressure water reactors, you'll have basically a lot of security and safeguarding issues associated with them. Whereas if we look at molten salt, heat pipes, and some of the other small modular reactors, those problems disappear. And then the IAEA flanging that together with IMO. That's kind of like the big thing there. Okay. Flag states, I mentioned, that applies to the ship itself or the offshore unit if you're certifying or classing to it. And then flag states might have extended set of requirements. Some, a few do, but not many. And then there are the open registries and national flags. So the open registries would be like the Marshall Islands, Liberia, Bermuda. Generally, if you pick any one of those on the Paris MOU whitelist, you're going to be in pretty good shape. And the flag states adopt and enforce the IMO requirements. They either do it through using the recognized organization status of a class society, or they send their own surveyors out. And the recognized organization is basically class societies are deputized into it. Port states, coastal states, those are the ones with more extended requirements. And a way to think about it is, in the US, they run towards a prescriptive line of thinking. In the UK, it runs to something called ALARP, or as low as reasonably practicable. Norway uses more of a duty of care, which is similar to ALARP, but not exactly. Class societies. Somebody this morning talked about dealing with aspirational ambitions. And this is where the class society actually can step in, is basically trying to create a framework so it all works. But one thing that I want to get across is that class societies develop minimum safety standards. These are not design codes like ASME B31 or the ASME boiler pressure vessel code. So it's an interesting area that we have to address. The class societies, we develop rules, minimum safety standards. We review the drawings, QA/QC those, survey during construction operations, QA/QC, that's what that is. And there are two different rule sets for ships and offshore systems. And they tend to be today a mix of prescriptive and, let's say, risk-based or goal-based standards today. Offshore tends to use more goal-based and ships tend to use prescriptive. And I think what we're going to see is because nuclear is so far out there, it's going to basically adopt an offshore mentality or the risk-informed approach and deliver basically offshore concepts and thinking into a maritime practice. If that sounds like a lot, the cultures of shipping and offshore are enormously different. So this is going to be an interesting thing to watch happen. But what's neat about the risk-informed approach is it gives you the room to be creative in a qualified way, because you're establishing the acceptance criteria of what you got to do, and if it meets it, that's good. SOLAS actually has a magic clause for equivalency in there. You can do whatever you want as long as it meets the intent of the original rule, but it has to be an engineering change, and you cannot use administrative or operational controls. So you have a magic clause in there, and the IMO formal safety assessment approach. It's a lot of work, but you can do some pretty cool stuff with it. Oh, that's a Brazil, offshore Brazil, probably about 2,000 meter water depth. Gas compression. Oh, you see that ship in the back right there? That's a shuttle tanker. That's bigger than an aircraft carrier for those of you who want to sort of see what the size is. So that's probably about 150,000 deadweight DP shuttle tanker. So the intent of this is to make it look complicated. Yes, it is very complicated. And what we're trying to do is we're trying to create a path. And the nice thing about the risk-informed approach is you can mesh things, untangle things, and create a path where as things get added on or changed, you can make it work, because you're still going back to the original performance criteria or acceptance criteria, however you want to put it together. This is important. I was at a Coast Guard conference on LNG as fuel, back in January. And someone from one of the nuclear OEMs was talking, and basically 1/3 of the room was just leaning forward, including the Coast Guard. Tell us more. How do we do it? Yeah, let's do it. We're ready. Middle group, which included the cruise ship operators, love it. We're going to be second. And the third group, well, they were still disappointed that we moved from sail to steam. So we'll just leave them be. But the important thing with this is the first one or two operators, their experience will shape the entire adoption of nuclear. So we need to be their cheerleaders as an industry to make it work. And we also need to play well with port states and coastal states. The first operators they'll have to do it, but they need to be resourced for time and money. So the charters are going to have to be involved with that. They have to be a backer. Few important details on this. The SOLAS changes, that has to bridge with the Atomic Energy Agency. If that bridging or tailoring is not done properly, it's just going to be disjointed in a total train wreck. Next thing we have to do, well, not in order, but simultaneously, influential flags. That's basically anything on the Paris MOU whitelist with a large tonnage attached to it. So I'm looking at Marshall Islands,
Germany.
yeah, Panama, Bermuda. But what's interesting is the U.S. flag could be going from almost no ships to a significant number of ships because of that nuclear regulatory building. Class rules, they need to be developed. They're still in a primitive state for this. We need to change our approach for design and construction into a design philosophy approach, which is more risk-informed, rather than just the straight shipyard designed to a single point with real life somehow thrown out. It's going to be different. We need to change relationships between the operator, the shipyard, and the OEMs. The shipyard is going to have to be treated as an OEM, and they're going to have to step up to that. And the charter and the operator relationships have to change too. They can't be just, I worked for 12 years in oil majors adjacent to a trade floor because that's how ships are chartered. It's got more in common with the Chicago Mercantile than it does regular ship chartering like you would think. The inspection, maintenance, repair, mariners love to get their hands on everything. We have to have this box, security, safeguarding box, you guys stay away. So that whole risk-informed approach again comes into it. So more monitoring instead of inspection. And then true risk leadership practices have to be adopted. In summarizing, 90% of everything will still move by ship, but there will be different cargo mixes in different ways or different ports. So your cargo and where they go and how they go will be completely different, but everything will still be on ship. So the nature of trade is on the edge of revolution. And from what I've seen in CERAWeek for the past few years, we're only starting to touch the surface. The nature of shipping is changing as a result of some of these pressures that are coming into place now. And for certain ship types, nuclear is an enabler for something really cool. When I saw the Savannah a few years ago, you got it. Anybody who ever has a chance to visit Savannah, please do. I guess to close out, always be optimistic, be skeptical, never cynical. That's it.
Thank you very much for this interesting presentation. If I have, let's say, no doubt that audience to help propel ships, I'm a bit more afraid about some context about nuclear energy. Well, the first one comes from, I mean, you need to get the resources, especially if it's uranium, and at this moment, the largest mines are in Kazakhstan, which is nicely surrounded by Russia, China, Iran, and Afghanistan. So it's quite a tricky position for this country.
So it's Canada.
Canada is promising, but not yet there. And so, I mean, will that be like a break for the development? Possible conflict resulting from the resources, or?
Well, one thing that shipping and commodities people are very good at is working in some bizarre locations. So I would say a good example of that is a book about Mark Rich called Metalman. And it talks about how Mark Rich left Salomon Brothers and became his own trader. And then Glencore over time is now one of the largest mining companies in the entire world. It's if you take a pure ethical standpoint, it's you might have to look at it in black and white or grayscale a little bit, but the world will figure it out. I'm optimistic on that, but it's outside of my range as an engineer to talk about.
Just a small second one. It's well, any ships sailing on nuclear power is never sailing alone. There's always a bunch of let's say, other ships protecting us on this reason. Could you imagine commercial ships just sailing around the world without additional
Yes.
protection?
Yes, like molten salt reactors are a good example of that. It has basically fuel which is so junky you can't even make a weapon out of it, even if you stole it. And if anything goes wrong on the molten salt, it has a negative feedback loop. So as soon as heat's taken away from it, it literally turns into a brick. And that's literally. Eric?
I'd like to express to you or tell you about my experience with nuclear power. And I recently became involved with the Nuclear Regulatory Agency Commission, NRC. And I was asking them, how do you go about regulating the 100 operating power plants in the United States? And I figured it would be something like the FAA on steroids, you know? It had to be hundreds of NRC people in the plant going through records and stuff like that. And they said, no. We have a risk-based philosophy, risk-informed philosophy of regulating nuclear power plants. And it was really fascinating. Basically, there's only really, I'm simplifying this grossly, but there's really only two separate requirements you have to operate a nuclear power plant. And one is you have to join the Institute of Nuclear Power Reactor Operators. This is an NGO of nuclear power plant operators that was formed at 3 Mile Island, okay? You gotta be a member of that. And number two is when you're building a nuclear power plant, you've got to create a quantitative risk assessment for the reactor design. And those are the only two things that you basically have to do. You know, if you're a member of the INPRO, you have to report to a database that's accessible by the Nuclear Regulatory. All your maintenance, all your failures, all of your near misses that goes in there. And what the Nuclear Regulatory Commission does is they audit to be sure you're reporting properly. Because if you don't report properly, they throw you out of the INPRO, and then you can't operate your reactor, you'll lose your license. But what they do is they look at all of these trends, the trends of failures, the trends of maintenance, and they make a determination how far they're deviating from the quantitative risk assessment that was constructed when you built the power plant. And then they take regulatory action, not based upon a compliance and inspection with a huge number of specific prescriptive rules. They look at the trends and they look at the quantitative risk assessment and say, we're having problems with this type of motor operated valve throughout the nuclear industry. We got to do something about it.
And then
It's a totally different thing than I'm accustomed to.
then if you follow along with that, yeah?
It's the same, it's classification.
No, it's different. No.
No, even in classification, the only difference is that in classes operate large classes of equipment. But if, for example, in an engine, when a problem starts arising in an engine, it feeds its way through the class system, they start to see problems, and then there's some reaction to it and go through it. It is qualitatively the same, maybe quantitatively a little different, but let's not forget that class existed before the FAA and before the regulatory.
The quality.
Let's not forget that the Savannah ran, unescorted as it actually should be in the international trade.
The quality and risk systems that are used, like what Eric's talking about, are basically the lower levels of that are what you see at the upper levels of offshore floating production. This is basically, if a surveyor is coming on board, it's a QA/QC check. It's really just a verification, but basically they're functioning on a much more interesting level. It's so they'll be involved with safety case, revising the safety cases. They'll be constantly checking the reliability and other factors, and they'll also be so paranoid of the right-hand side of the bow tie. It's a different mentality.
That's just, driving the steering wheel just makes them drive, it makes you pay more attention.
It's different thinking.
You're still turning the steering wheel.
Yeah.
Peter, thank you very much.